The C2-14D1 is the digital input-output module that we use with our PLC. You can get this PDF from the Automation Direct site by typing in the part number of the slot and then go to that page and download this PDF here. So let's review some things about this. We've got inputs per module 8. Nominal voltage is 24 volts. And an input range that they're going to want to see is 21 to 26 volts. Now, since these drive LED optoisolators, the typical input current is going to be 6.5 milliamps. And with an input impedance of 3.9 k ohms. So any voltage greater than 19 volts will record as being on. Any voltage less than 2 volts will record as being off. And here's a response time. You have 5 microseconds maximum. 3 microseconds is typical. That's micro, not milli. And for on to off, you got a 1 microsecond typical and 5 microsecond maximum. And you can see the status indicators. You've got 8 green LEDs that are up here, right up here in the top. So the top half of the card are for the inputs. Now the bottom half of the card with the red LEDs are the outputs, and we have 6 outputs. I'll scroll down here. You've got 6 syncing outputs. I'll talk about that, what that means by syncing or sourcing. And it will work in any voltage range between 5 to 27 volts and connecting up to 4 to 30 volt power supplies. You can do 0.1 amp per point. It's 100 milliamps. If you need to drive something more than 100 milliamps, you'll have to get a different card. Now keep in mind, you've got 0.4 amps per common and 0.2 amps per common on C4. And that's just an accumulation of all of the 0.1 amp per point. Now the next page is a lot of safety information and opening and closing and handling these. Make sure you review all of that. And now here's the wiring diagram. They support 16 to 28 gauge wire. I ended up using 20 gauge wire on mine, and they recommend crimping ferrules. The ones that I used were right on the edge of maybe being too big, but they ended up fitting. Now they're showing different inputs here, syncing or sourcing. This connection right here is what we're using. You're running it through the switches. Now it shows normally open switches here, but you can connect normally open or normally closed, whatever you want. Ignore the battery connection here that's on the right. Now for the outputs, it's the same thing. You've got your power supply here with the positive wired up to all of your loads. So the positive wired up to all the loads, and then the other side of the load goes to the output where it will connect it to ground, and it gets the ground through C3 or C4. You also need to go and connect your 24 volts up to the plus V, and that was the one wire I left off of the diagram. And here's your equivalent circuits for both your input and your output. You can see the 24 volt supply connected up to the input switch. When that switch is closed, it allows current to flow through this diode and then back to the common. And that diode is an LED inside there, optoisolator. It'll light up and then turn on this output. That output then goes to the PLC. Very similar. You've got optoisolator from the PLC. In the case the PLC will drive this to ground, put that low, and that allows current to flow through this LED and actuate this output. That output will turn on, drive this MOSFET, and that connects it to ground. So your load here with the positive on one side will then be connected to ground through this MOSFET. Now these diode here is a protection diode for that MOSFET, but if you read in their specs, if you have a inductive load out there, you need to put a diode across that inductive load. And I'll go over to chapter 3. This is from chapter 3. Okay, this is chapter 3 from your help file, and this is an important file to go through. Again, it's talking about the syncing and sourcing of your wiring. Down here it talks about the relay outputs, which we don't have, but it then goes in and talks about coils and the spikes that are present on coils when you turn them on and turn them off. And that is important because if you drive a relay with this output, you need to make sure that you put a diode in parallel with that relay. Read about transient voltage and why it's bad. And there's the diode that's inside that I just showed you, but you need to put an additional diode because you can see it just doesn't do all the work that's needed. And here you go. And this is the type of output that we're doing. It's syncing, they're connecting, the switch is connecting your relay or your load, whatever's outside of the PLC, to ground. You're wiring it up with 24. Sourcing means the switch is connected up to the power supply, and open and closing, turning off power to the relay. And see the back side of the relay is then connected up to the power supply minus. And with these diodes in parallel with the relay coil, you can see that the spike is kept at a much more, actually a very comfortable level for the PLC. Come back here to the diagram that I made for you. You can see your inputs. You've got your minus 24 connected up to each of the commons. And your inputs, one side of each switch is connected up to positive 24, and then the other side of each switch is connected up to an input. The first two are normally open, the next two are normally closed. Your selector switch, its normal, is in the normally closed position, as are the limit switches and the last push button. Now over here you've got the power connector. That's the little gray power connector that's on the side of the PLC. That's where you bring in the power to it. This PF line is not connected to anything, so you could ignore that. Then your output section. As you see, we're bringing again the minus or the ground, whatever we want to call it there, reference. It's not really grounded because we did not ground the power supply. It's the minus terminal on the power supply is connected up to all of these commons. Now the plus 24 is connected up to each of your loads, and then the other side of the loads connect up to the output, and when they're connected to ground, they'll turn on. And this is the last wire that I missed on the previous diagram, is going from the plus 24 to the 24 volt input on that card.